0.6, working with algebra of functions. So this is also called function operations. So your basic operations are add, subtract, multiply, divide, nothing new on something like that. We have another operation called a composition, but we'll be doing that a little bit later on. So we're just worried about the add, subtract, multiply, divide. So when we are looking at multiple functions here, let's just say f of x equals 3x plus 1, and we'll go g of x equals 7x minus 5, something like that. Right? So we got a couple different functions here. And remember, we use our standard function notation, f of x, g of x, what have you, just simply because it helps us distinguish. Are we talking about f or are we talking about g? Well, when our operations come in, or that algebra of functions, we're looking at things like this, f plus g of x. This would be the notation that we would have. So the operation's obvious. You see the addition sign there. We're going to be adding. So when I expand this out, it would be f of x plus g of x. So I'm being asked to add the functions. That's the part I'm going to do, which would give me then 3x plus 1 plus 7x minus 5, and then we're back just combining like terms. So basically, one of the things that we did earlier on was go through and combine like terms, things like that. That's not new. What's new showing up today is just a different setup, actually working with the function notation. This would give us 10x minus 4. That would be our addition of the two functions. Right? So again, we talked about in this class, we're going to see a lot of things that kind of repeat. We've seen the combining like terms and such. That's not new, but now we're getting another new look as how it can be presented. Okay, and we've got to be comfortable working with all those different looks. Let's switch. I'm still sticking with this f and g here. Let's go g minus f of x. So now we're subtracting, and it's just going to be in the order that we're given. So g minus f of x I can rewrite as g of x minus f of x. Now the one thing we want to remember on the subtraction is we still have to be careful of that negative. That's something we've seen before. So if I write this out, g would be 7x minus 5 minus, and then the 3x plus 1, the entire f of x, because I need to make sure that I'm going to go through and distribute that parenthesis. Technically, parentheses would be around both parts. Even back here in the addition, you'd have a parenthesis around both, but you're adding, so it really isn't going to matter there whether you have them or not. It's not changing anything. But when you're subtracting, the order does matter. So we're going to have to make sure we distribute this. 7x minus 5 minus 3x minus 1. So 4x minus 6. So again, different look, same idea. We've distributed a negative many times. Nothing new on that piece there.
Doesn't matter which, the g of x has to go first.
The g of x goes first in this case because I wrote it first. So really, as far as what's coming first, we're obviously looking right here. There's no tricks. That's the order. Okay. So on the last one, yeah, f came first because that's what was written first. Right? And now in addition, what you'll remember from the past is order really doesn't matter in addition. But it does matter in subtraction. So we've got to make sure we get that order right the way it's written. Our third operation, I'll write it like that, fg of x. So what we want to remember is side by side is multiplication. Now in your textbook that you have right now, they will initially show it to you like this, f dot g of x, which is still multiplication. But after that, you're never going to see that dot again. They're always just that side by side. So we just need to remember, we know side by side is multiplication. We've seen it many, many times. Nothing new there. Okay? My f is, so we're going to have f of x times g of x. F is that 3x plus 1. G is the 7x minus 5. I just again wrote the f one first because that's what was presented first. Now I'm just going through and doing my multiplication. So again, nothing new on the multiplication. You've multiplied those kind of things many times. Just a new look on the very start would be the difference there. So here we'd have 21x squared. Let's see, minus 15x plus 7x minus 5. 21x squared minus 8x minus 5. Using our distributive property or FOIL method there. It's a pretty common on that. Our fourth operation, fourth primary operation anyway, add, subtract, multiply, divide. So I'm going to say, right like this. G divided by f of x. So again, the first one I see is the one that I write first. In this case, G is the first one I see, so G is going to be on top. So I would have G of x divided by f of x. All right, so the G one coming in on the top there. So in this case, 7x minus 5 over 3x plus 1. Now, a couple things with regards to division. First off, there's not really, in this case, any kind of simplifying that can be done. If there was something I could factor or reduce out, I would. There's not anything here. It's kind of stuck. So there's really not much to do as far as simplifying. The division, though, does have a domain. Domain would be x cannot equal negative 1/3. Now, we have talked about domain. The idea of domain is not new. We are getting a little bit of a different look here. I say a different look. We've seen division. We know what division looks like. That's not a big deal. We know the idea of domain. What's happening here is we end up with a domain restriction simply because, remember, we can't have a 0 in the denominator. That would make it undefined. So let's kind of review here, and I'll talk about that negative 1/3. Here's my two initial functions. If you look at both of those functions, they're nice linear functions. They're lines, which means their domain is all real numbers. Okay? You can substitute anything for x in here you want, and either one, you'll get a y value out. Everything works. Okay? So when I add two functions that have infinite domains, or all real numbers, I'm going to get one that, hey, still all real numbers, not a big deal. Still linear. I subtract two with those domains. I'm still getting one with a domain of all real numbers. When I multiply, all real number domain, I'm still getting one, all real numbers. You might remember somewhere from the past that even though you might not know exactly where that graph is, that's a parabola. You got that square shape. So we have something there. But anyway, I can substitute anything in for x. Division causes a problem with domain. So I can't, this is still my division process, but I cannot have a 0 in the denominator. That would be the domain restriction. And sometimes I think that the domain restrictions for a fraction are really easy to see, and sometimes not so easy. Here's one that I think is really easy to see. Make something up here. Let's go. Hey, 3 over x minus 5. What can x not be? 5. Makes 0. 5 minus 5, 0. That's pretty simple. All right. 2x over x plus 4. What can x not be? Negative 4, because negative 4 plus 4 makes it 0. I think that's a lot easier to see. Sometimes we struggle a little bit when I see a 3x plus 1. Sometimes it's not as easy to just look at. But if you go out to the side and just do, all right, 3x plus 1 equals 0 and solve it, you'll get your negative 1/3. Right? So if we get one that's really simple to see, great. If we get one we have to go out to the side and solve, we can do that. Now, if I flip this division problem around, it's actually going to change the domain. So let's say I wanted f divided by g of x. So now f's first, f's on top. So we're going to have f of x divided by g of x, which would be down there, 3x plus 1 over 7x minus 5. There's my division function. Again, f on top because it came first. And this is going to produce a domain restriction. So my domain restriction, I'm looking right at that denominator and trying to figure out what makes a 0 in the denominator. X cannot be, and that might be easy to you. It might be difficult to you to look at. If you're unsure, remember, you can always just kind of go out to the side, set that denominator to 0 and solve. So we'd move the 5 over. 5 by 7 can equal 5/7. So what I do know is, sometimes this might be difficult to see, but I do know for a fact you can go out and solve that linear equation. That you've done many times. Nothing new on that. Our operations, or our algebra of functions, also take a numerical sense. So let me give you two different functions here. I'll call this one, I'll just call it a of x. A of x equals 3x plus 5, and we'll go b of x equals x squared plus 2. And again, just using a and b, trying to get a different look. Our most common is f for function, but we've got to be comfortable seeing other variables used. It's not going to matter to us. So here's a numerical representation. Let's say I want a minus b of 3 instead of x. So I want a minus b of 3. Now if I rewrite this, it would be a of 3 minus b of 3. So when I had x's in there, and I've still got a couple of these on the board, what I did is I rewrote them. Each time I rewrote what I was doing. Now I'm rewriting it with a 3 instead of an x. So instead of a of x minus b of x, I've got a of 3 minus b of 3. Now there's back to our function values. We've done a of 3 before. We have found function values many times. So now we're looking at them again in a different format. So a of 3. This is where we put 3 into the a function. So I would get 3 times 3 is 9, plus 5 is 14, minus b of 3. 3 squared is 9, plus 2 is 11. I get a value of 3. Now, not too long ago, we were finding function values just out to the side. Right? F of x equals something. Found, say, f of 2, f of negative 1. Now we're just seeing it put into a different format. Let's go a plus b of negative 2. So I'll stick with these same a and b functions. So I'm going to have a of negative 2 plus b of negative 2. And now I'm going to substitute and find my values. A of negative 2, let's see, that'd be negative 6. Plus 5 is negative 1. B of negative 2, that'd be a positive 4 when we square it. Plus 2 is 6. That'll give me a value of 5. Okay there. Let's look at our product. Let's go AB of, let's go negative 4. There. So I'm going to have A of negative 4 times B of negative 4. There's my rewrite. So A of negative 4, that's going to be negative 12 plus 5. Negative 7. B of negative 4, 16 plus 2 is 18. And let's see, what would that be? 126? Negative 126. Check my math there. Does that sound right? I think it's right, but I make mistakes just like everyone else. Nice thing for you. Function values, not new.
That's right.
Is that right? Okay. Function values, not new. We've done this stuff just independently, not combining with addition or subtraction or multiplication. We've done them independently. So that's not new. We've combined like terms. We've multiplied. What we're getting is a new little format here as far as the way it initially looks. And we talked about that over and over. Just getting comfortable with a different look on something we've done. Take the time to do the rewrite. Not always necessary, but it can help you tell you exactly what to do. My rewrite still in this multiplication. Told me, hey, write the first one, multiply by the second one. Now I'm really looking at something that's familiar. I'm getting back to something I've done before. That's our focus. All right.